All right, in this section we're going to be studying properties or rules of logarithms. The first three properties are going to be used to reduce long expressions with logs called condensing, as well as unreducing short expressions with logs called expanding. The last property will help us calculate estimates of logs using a calculator. Okay, so our first log rule involves the product rule. So this is where inside a log, so you kind of look inside here, inside a log we have a product of some type going on. What this product rule allows us to do then is allows us to break up the product into a sum of two logs. So log base b of m plus log base b of n. All right, so to illustrate that first rule, we're just going to look at some expanding cases. So here inside the parentheses, we are multiplying 7 times x. So in the expanded form, this would be log base 4 of 7 plus log base 4 of x. Here, we're multiplying 3 things together, and so we're going to break this up into 3 sums. So log base 8 of x plus log base 8 of y plus log base 8 of z. And anytime we're multiplying inside the log property allows us to break up the product into a set of sums. Uh, Going reverse and condensing, here we are adding 2 log statements together so we can bring it together as a product inside the log. So log base 4 of 2 times 5. And of course 2 times 5 we can simplify down to 10. In the next example we've got log 25 plus log x. So we can bring that together as log of 25x. And then that's it. The next rule we're going to look at is the quotient rule. This is where we are dividing inside a log. And when we are dividing inside a log, we will break this up as a subtraction. Okay, so let's look at some examples of that. The log base 7 of 19 over x, we can break apart as log base 7 of 19 minus log base 7 of x. And in the next example, we've got ln. Remember, ln is just log base e. Kind of remind us of that. And so when I split this apart, I get ln of e cubed minus ln of 7. Now, hopefully you recognized the property that ln of 3 simplifies down to. And the last lesson, we actually looked at some simplification rules. So if you recall, we said that if we take ln of e of 3, set that equal to x, well, ln is log base e of e cubed equals x. And then if we rewrite that into exponent form, we get e to the x equals e cubed. So what is x? X has to be 3, right? So this ln of e cubed actually simplifies down to the number 3, so we get 3 minus ln of 7. And that I would expect you to recognize that you can apply another property in that when we apply the quotient rule. Okay, under condense, we're going to go the other direction with practicing the quotient rule then. So here we're subtracting 2 logs, and so I can bring that together underneath a single log. And one thing that we have to clarify is what goes in the numerator, what goes in the denominator. The term that has the minus is actually what goes in the denominator, and the one in front, obviously, we have to put in the numerator. And that's it. That one doesn't simplify anymore. Over here, we have log base 4. Okay, what number goes in the up top? That's 16, and that's a 2. And we actually can simplify that down, because 16 over 2 reduces down to 8. Now, you're probably thinking, well, at that point, we're done. Okay, but remember, there's a way that we could actually simplify this even further. So if we kind of think about this as equal to x, and if I rewrite that into exponent form, I get 4 to the x equals 8. Okay, well, what's another number that I can rewrite something to this power equals 4 and something to this power equals 8, and that would be 2. So we get 2 squared raised to the x power equals 2 cubed. And again, another exponent rule is an exponent times an exponent is multiply. Okay, and so the only way that the left side would ever equal the right side is if those exponents match. And so we get x equals 3/2. So this entire expression actually simplifies down to 3/2. The last rule we're going to look at is the power rule. And the power rule allows us to take an exponent that's inside a log and bring it out front as a product of the log. So here I would take the p and I would bring it out front of the log, so I get p log base b of m. Okay, so let's look at these examples here. So that 4 I can bring out front. So I end up with 4 log base 5 of x. And that one's done. Okay, so here I can bring the 5 out front. So 5 log of 4x. And then just kind of think for a second, is there any other property that I could apply? And yeah, I can actually have got a product, and we can split that up into a sum. So 5 times log of 4 plus log of x. Now you're probably thinking, where'd the parentheses come from? Why did I need those? Remember, it's 5 times the log of 4x, so it's 5 times the sum. It's got to be 5 times both of them. And for right now, that's an acceptable form. There might be a reason why we might want to distribute the 5, but for right now, we're fine. And then the last example under expand is that ln of the square root of x. Now, these are all supposed to be examples of an exponent, and right now I don't see one of that. But remember, a square root is equivalent to the power of 1/2. So now it fits the form of the others. So I can bring the 1/2 out front. So it's 1/2 ln of x. And so that's that answer. Might as well box this one, so we like boxes. Under condense, so I'll come down here. Got several examples here. So here I can bring that 2 up as an exponent. So log of x squared. And that's pretty much it. Then I can bring this 4 up as an exponent. So log base 5 of 2 to the 4th. Now 2 to the 4th we can simplify even further because that would be, let's see, 2 cubed is 8. So 8 times 2 gives us 16. So log base 5 of 16. All right, then we have these here. We've got several statements in a row. So we can bring up all of those numbers as exponents. Okay, so let me rewrite this then just with bringing up the exponents. We got log base 5 of x to the 5th minus log base b of 6 squared minus log base b of y to the 1/2. Okay, now we have to remember for a second what being positive and what being minus negative means. So the fact that I see any negative at all when I'm subtracting logs tells me that I'm dealing with a fraction of some kind. And the minuses actually indicate to me whether it goes in the numerator or the denominator. Anything positive goes up in the numerator, so that's x to the 5th. And anything negative actually goes in the denominator. So the negative, as far as logs go, don't mean a negative number. They actually mean that we're dividing by something. So here, log base b of 6 squared is 36, and the minus is with the y, so that tells me the y has to go in the denominator. And of course, what does the 1/2 mean? That means we're dealing with the square root of y. And so that's our final answer. Same thing here, we'll bring up that cubed. So we got ln of x plus 7 cubed minus ln of x. And the ln, the minus actually tells me that I'm dividing. So something has to be in the numerator. That would be x plus 7. And something has to be in the denominator. And that would be x. On a graphing and scientific calculators, there are actual buttons, the logarithm buttons, that allow us to do various features. So we've got the natural log button, or the ln button. Remember, that's log base e of x. Or we have the common log button, or log x. Remember, that means log base 10 of x. So typically, and I'm going to pull up a TI-84. TI-84s usually have it right above the store button. You'll see the log and the ln button. And those are the two buttons that I'm referring to. Okay, so notice, I'm going to pull my calculator up here. If I wanted to do any other base besides E or 10, we don't have a button for that. And a lot of times you can search around the math menu, and it used to be that you didn't have a function that'll do that. Some calculators nowadays are starting to see that more and more, which kind of means this whole process is mute. But for the most part, you should just have access to a log or ln button. And honestly, with the formula I'm about to show you, that's fine. Okay, so kind of read through then. For the most part, there's no log buttons for any other base other than 10 or e. And so if you need to estimate a logarithm in decimal form with a different base, you're going to need to use what's called the change of base formula. Now, in general, the change of base formula says that we can take the log of any base of m over the log of that same base of b. So we want to use that number and that number to set up our change of base formula. Okay, more specifically then, using the two buttons that we're aware of, this would look like log of m divided by log of b, or if we want to use the ln buttons, ln of m divided by ln of b. Okay, so in these examples, we'll kind of use both the log and the ln button to kind of compare. So let's see, log base 5 of 140. We'll start with log, would be log of 140 over log of 5. And that's actually the same as the ln of 140 over ln of 5. So once I've picked which base I want to go with, then I'm going to open up my calculator and I can type that in. So we'll go log of 140 divided by log of 5. And I get some decimal, 3.07. And just to kind of show you that it doesn't really matter whether you do log or ln, if I do ln of 140 divided by ln of 5, I get the exact same number. So we get about 3.07. Okay. Now the question that I kind of want to follow up with, what is so significant about 3.07, the 5, and the 140? What does that all have to mean? And the answer is that if I take 5 to the 3.07 power, I should get something close to 140. So let me kind of show you that, just so you can kind of see that. So 5 raised to the 3.07 power. And notice I don't get exactly 140, I get 139.9. So my follow-up question would be, well, what happened here? How come it's not 140? Well, remember, it's not 3.07. It was 3.07 with several other digits along the way, so we're still right, even if it doesn't match exactly. Okay, next up, we got log of base 4 of 15. So we'll just do the log button there. And so once I've got it written out, then I can pull up my calculator. And I'll clear this out. So log of 15 divided by log of 4. And I get 1.95 about. Sorry, approximately 1.95. And then the last one, log base 2 of 100. Well, this is log of 100 divided by log of 2. And so we'll go type that in. So log of 100 divided by log of 2. And I get 6.64. And that's how that works. Okay, so in summary, the 4 properties that we've learned in this lesson are this product rule, so the log base m plus log base, base b of m plus log base b of n, we can rewrite as log base b of m n being multiplied. Then we have the quotient rule, so log base b of m minus log base b of n translates to log base b of m divided by n. Then we have the power rule, so p times log base b of m I can bring up as an exponent. And then we have the change of base formula, which gives us log of m over log of b, or ln of m over ln of b. Kind of lets you pick and choose. Okay, so and the reason why we need all of these rules, among with other rules that we've seen, is in the next section we'll actually use these things to solve logarithmic equations.